This is the Debunking Economics podcast with Steve Keen and Phil Dobbie.
The Archives.
Episode 138. Nordhaus's climate model debunked.
Welcome to the Debunking Economics podcast with Professor Steve Keen. I'm Phil Dobbie. And today, William Nordhaus. He's a Nobel Prize-winning economist. And unlike most of the profession, he's concerned about climate. And he's trying to find a way of using economics to solve the issue of sustainability for planet Earth. But does he have a genuine drive? And is he searching for a solution that doesn't exist between two forces that are really mutually exclusive? That's today on the Debunking Economics podcast. So maybe we should be grateful for small mercies that one of the winners of the Nobel Prize for Economics this last year was a climate change champion of sorts, William Nordhaus, who believes that global warming is real and economics should do something about it. And he's trying to find a way of mitigating the impact of man on the climate without impacting our growth and our standard of living. So, Steve, I mean, is this possible? Aren't they mutually exclusive? Isn't it all a bit of a dream?
It is a dream, and in fact, I think it's a total nightmare because when it first happened, I had a similar reaction to you. Okay, it's good at least somebody getting recognition for doing work on the economics of climate change. Then I remembered that Nordhaus's claim to fame, the way he got to be famous in the first place, is trashing quite viciously the limits to growth study back in 1972-73, and being the person who probably led the charge of neoclassical economists to undermine the credibility of that particular study. And so that made me negative again. Then, of course, now I had to have a better look at his model. And even on a neoclassical scale, this is worse garbage than even I expected with that foundation.
Well, it's the DICE model, isn't it? The Dynamic Integrated Climate Economy model, which says the world GDP is reduced by only 1% with an increase of 2 degrees centigrade, 4% at an increase of 4 degrees centigrade, and 8 to 9% at an increase of 6 degrees centigrade. Now, from my reckoning, if we get an increase of 6 degrees centigrade, aren't we all dead or pretty close to it?
This is the thing, and this is why I look at it. You've just got to be kidding, because the way he actually derided the limits to growth was he had one of his papers was called "Limits to Growth: Measurement Without Data," and he basically said they've got all this faux fitting of the data to the model's parameters itself, but really they haven't done it. Well, I would actually call him functions without forethought, because what he actually uses to supposedly work out the environmental costs of climate change is a quadratic function. So he says the amount of damages are a quadratic function, A times x plus b times x squared, where x is the increase in temperature over pre-industrial levels or over the levels that apply right now. Now, that itself is bad enough, because if it's quadratic, then it roughly says that an increase in temperature of 6 degrees will have 36 times the damage of an increase in 1 degree. But 36 times, a substantial number is a very substantial number. So you could still, even being quadratic, you could still get some sort of reasonable estimate out of there. Then I had a look, and I simply couldn't believe the parameter value he had for his little quadratic equation, because he completely left out the linear term. He left out the first power order as well. So there's no constant. There's in the value for A, if you think of A plus BX plus C squared, A was 0, B was also 0. He only had a term for the x squared element of the temperature, and that coefficient, and I quote, is 0.00267. Now, that is 1/500th of the increase you get from squaring the temperature change is taken as a damage to the planet. Multiply that by 100 to get it percentage terms. So what it ends up being, and this is just it just takes my breath away in many ways. That's where he gets this idea that a 1% increase in temperature, as you said, because what was the number again?
I think 1% is 2 degree. I don't know a percentage in temperature, but a 2 degree increase is only going to reduce GDP by 1%. 4 degrees is going to increase it by 4%, which doesn't sound very quadratic to me. It sounds a bit linear, but anyway, an 8 to 9% reduction at an increase of 6 degrees. So in other words, if we get to 6 degrees C, which is I mean, the IPCC is reckoning we should be aiming for 1.5 degrees. So if we get 4 times that amount, the impact on the economy is going to be less than 10% of GDP.
Yeah, and I'll take you further. The reason it looks like linear is because you've got an incredibly small constant multiplying the power terms. 0.002, 1/500th of it. For a long time, the 1/500th that dominates the x squared level, and x is very small. Now, if I feed in 10-degree increase, that's going to reduce GDP by 26%. Exactly. We should have laughed at the fucker. Pardon the phrase.
Well, I mean, and the reason why it would decrease by 25% is because 1 in 4 people at least would be dead, and therefore
not 1 in 4. No. The last time we had 10-degree higher temperature than the planet currently experiences on average was the Permian extinction, when 95% of all life forms died.
Well, there we are. Right? The last 5 are going to be so productive in that case, aren't they?
Absolutely.
Working their asses off to maintain GDP. That's right.
I mean, it is just laughable. Simply laughable.
So is his model wrong, or is it just the inputs into the model? I mean, because there's, as I understand, he's put quite a lot of work. It's a reasonably complex model, isn't it?
No, it's not. Well, it's a complex model in terms of it's a neoclassical growth model. It's called a Ramsey growth model. The idea of a representative agent living for an infinite time, making decisions between consumption and investment to maximize utility through time. That's the whole crazy notion that gave us the real business cycle model. That's what it's actually built on. So he got rid of the limits to growth by disparaging the hell out of it, and we didn't get the development of system dynamics we could have got if people had actually appreciated the technology properly. And instead, we got this bloody, stupid neoclassical piece of garbage being developed by him, along with a number of others. There's 3 other models that are quite similar. But when it comes down to what they have calibrated the wrong functions. And this is the crazy thing. It isn't just that they've got this neoclassical growth model and so on. They're using a quadratic form. Now, a quadratic, as I said, if you have, like, you can actually, I'll type in the numbers. Let's see, a 25-degree increase in temperature will cause 160. Give you 166% as your divisor, 1.6 divisor. That'll mean GDP is 1.6 times lower than it would have been without climate change, with a 25-degree temperature increase. Right. Now, so a simple
linear model where it actually said, well, at what temperature do we all die, would be more accurate in that case.
Well, that's what I'm thinking. What functional form would make sense here? Because if you look at the level of temperature increase that will wipe off life on the planet, and of course we know what happened with the Permian extinction was fundamentally the increase in temperature, the increase in carbon dioxide with the carbon dioxide event. I mean, it took a lot longer than we're doing right now. Dissolved ended what's called the thermocline layer in the ocean, let all the hydrogen sulfide living organisms, anaerobic processes to take over the biosphere. All this stuff came out to the top, dissolved virtually everything that breathes oxygen. And then only about 5% of life forms survived, and it took about 10 million years for the planet to recover. Now, how do you bring that into what's the simplest possible functional form that can give you that result? Bearing in mind the other extreme, if you had a 10-degree fall in temperature from where we are currently, then that would possibly push it back to a period which is also in Earth's history called Snowball Earth, where basically its fall in temperature meant that the glaciers expanded virtually without limit. As they expanded, because they're white, they reflect light back into outer space. So more and more of the radiation falling on the planet was reflected back, pardon me, without driving up temperature. And the consequence was the entire planet became enclosed in a ball of ice. Then that melted down because with no life forms generating any oxygen out there, or carbon dioxide for that matter. Pardon me, I've got a cough again.
It's like it's too much carbon in the atmosphere. That's what's doing it to you.
Yeah, well, you're right. Yeah, but what actually happened with the carbon dioxide was restored by volcanoes over millennia, of course, the thousands of millennia, pumping carbon dioxide and other gases into the atmosphere, which then gave you a greenhouse effect, melted all the ice, and back you went again. There's about 3 or 4 periods of that before we had the evolution of multicellular organisms. Now that gives you the function that fits that is 1 over a quadratic. A quadratic is a plus bx plus cx squared. You can factor into a minus W, A minus B multiplied by, X minus A multiplied by X minus B, give you values for A and B, that'll give you a quadratic. 1 over that gives you the right sort of function, because what you get is a thing with asymptotes where X equals A or X equals B. Now, if you set A to be plus 10 and B to be minus 10, that says that if temperature increases by 10 degrees positive or 10 degrees negative from where we are now, life will disappear, because in one case will dissolve and the other case will be encased in a roll of ice. That's the function you need. Now, I've done that, of course, a very quick little calculation. So if I feed that information and I say, let's make it match Nordhaus's fantasy at the same level of temperature. So I've got them matching at a temperature of, let's see, hang on, it's up this one. Okay, temperature increase of 5.5 degrees. So I match the two functions. Let's see, that's not quite 5.5 here, 5.68. Okay, if you then head out to a temperature which is, say, let's go for 10 degrees over, okay, 10 degrees over, then Nordhaus's calculations are telling you then you get a 12% fall in output. This function, which we should be using, when you start to approach the 10 degree value, let's say you get to the stage where you're at 8 point, I think you say, that's what I've got here, 6.6 degrees. Okay, 6 degrees. At that point, you're at a value of 180 times the level of damage at 1 degree, and you get to the point where there's nothing left. So the functions completely diverge very, very rapidly. So simply putting a more realistic function even into his model would give you infinite costs of hitting a temperature of 10 degrees.
Right.
And therefore, when you discount infinity by whatever discount rate you care to apply, the cost of temperature of global warming is infinite, and therefore you bloody well do something about it. But he's actually one who's been arguing in favour of doing it slowly and letting economic growth take
so isn't that part of the problem? I mean, I have two questions from all of this.
Yeah.
I mean, any model that, it's clear at some point within it, there's an end point where everybody is dead. GDP has to be zero. If his model doesn't show that, how do you become a Nobel Prize winning economist?
Because other economists believe the same delusions you do are the ones doing the selecting.
Right. Or haven't examined the model enough. I mean, surely any model is going to say, well, okay, there's a point here where there's nothing at all happening. Therefore, the model is not sacrosanct if it doesn't come out with that result. Surely.
Yeah, surely. But unfortunately, it's not what happened. I mean, I look at this thing and I think, how did anybody let this thing pass muster? And it's a sign of just the desire economists have to just wash this whole thing away.
So is he just retrofitting numbers then? Is he putting in assumptions into his model so everyone goes, oh, look, we've got a mathematical model. That sort of makes sense. And look, we don't need to do too much. It's not as bad as we thought. Because he's basically saying, yeah, we can live with temperatures of 3.5% warmer than pre-industrial levels, which is
3.5 degrees, yeah.
3.5 degrees, sorry, which is twice what the IPC reckon we should be aiming for. And it's not going to cause too much hurt in the economy in the process. So everybody loves him.
Yeah, and that's even before feeding into the rest of the stupid model. This initial function is so insanely bad. But of course, if you fit one of these, if you're fitting a model which is continuous, doesn't have a break in it, and that's what a quadratic is like, and you fit it to a few data points close to zero, then it's going to be fairly flat. But if you then try to fit that same function to a point at which you have a literal breakdown of life on Earth, which is the 10 degrees level, then at that point, your function has to have an enormous value for that coefficient. Now, he's chosen, because he's got the wrong function, he's fitted it at the wrong end of the data as well, rather than that coefficient being, and I'll just go back and check it again, pardon me, hang on a second, 0.00267, it should be something like 20. Now, of course, you simply can't fit that to the actual data. It's wrong at both ends. So that would imply zero. If you use that factor, then a tenth of a degree increase would be showing us causing a 20% fall in GDP, which is wrong. So you're fitting the wrong function to the data, even if you're using the right data in the first instance.
So there's been criticism of the discount rate in his models, that he is not valuing future generations as high as current generations. So that would mean it's a short-term model for a long-term problem, wouldn't it? Which is
exactly, yeah. And there's a good argument in favour of whenever you're looking at if you're looking at your rate of return, then of course you're going to discount future returns. If I say, okay, let's say I owe you $10,000, mate. Then I say, look, I'll give it to you in 100 years. You'd go, get out of here. That's worth nothing to me. Even 20 years, that's worth very little to me. So it makes sense to extend. But if I say, I'm going to treat your kids as worth nothing to you in 60 years' time, you say, excuse me, I want to have, I care about my children. So the fair, when you're looking at over global, a systemic level system, then you should not discount at all. The future, people in the future are just as important as you are, thanks very much. The discount rate should be 0.
Yeah.
But he applies 6%. Now, what that means, I was expecting when I was...
Which is scary, because I think the Stern review went through exactly the same process as well.
Yeah, and the sensible argument is it should be a 0. You're looking at, you don't discount people in the future against for you. To basically treat people in the future as the same significance as people today. Otherwise, you're saying, I don't care if the human race survives. Now, so he proposes a 6% rate of discount. Now, my expectation when I started looking at this stuff was that would be the main cause of trouble. But he's discounting at 6% damages that themselves are trivial to begin with. And there's one more problem, which you might not have spotted because this is more my sort of thing, mathematical equations. The way he imposes the damage function is that it's a divisor of the output level. Now, the output level is given by the typical neoclassical Cobb-Douglas production function, which is output as a function of labour and capital employed. No role for energy whatsoever, which of course is one of my bugbears, bringing energy into the equation properly. But he assumes that continues growing anyway. So all he's doing is discounting an assumed rate of growth that never changes. So it is a horrifically bad model. And this, I've talked about forming the Nobel Prize in economics. He's truly, I could be hard to think of a more worthy recipient of the Nobel Prize than Nordhaus.
Right. Well, you'll be able to award it to him this year then, if he's ready to take it. Look,
I'm sure he'll have it. Yeah.
The question, of course, behind all of this as well, apart from the model doesn't stack up, is why we're looking at GDP anyway. Is that really a good measure? To his benefit, this seems to make sense. He worked on the measure of economic welfare, which rather than looking at GDP, rather than just looking at income, it measured income distribution and also the impact of environmental degradation. Now, he might have got the figures wrong, but at least it's a step in that direction, isn't it? Because, GDP is... If we look at GDP as a general measure of the impact on the economy, and we're looking at, the effect of global warming. So if let's take fish, for example, contributes diddly squat to GDP of most nations, but if we lost all the fish because the water got too hot, we'd have a pretty bad diet. Not to mention, we'd also lose the barrier reef. So there's a danger, isn't there, of drawing everything back to this economic number, which is GDP is not a good number. And he's at least taken a step in the direction of saying, well, if that's not how we want to measure all of this, we need to look at something else.
Well, that's one of the things that makes him a difficult character in that sense, because he does occasionally make sensible concessions to reality, and therefore he looks like he's progressive. Same thing as Paul Krugman, who makes sensible concessions to reality occasionally, and then is taken as trustworthy on macroeconomics, which he's not. So the same thing for Nordhaus. Yes, it's correct to say GDP is not a good measure. He does make some good noises in the direction of how it could be reformed. I think my idea is a damn sight better, which is to base it on energy. And that's one empirical piece of work I want to get done in the next couple of years. But he's mouthing the right sort of stuff. And in that situation, the type of energy stuff that I'm coming up with, and Bob Ayres and Tim Garrett and so on, doesn't get listened to. Because listen to Krugman's, to Nordhaus saying here's a way to reform GDP a bit. So in some ways, the way that they are progressive, even even that does damage to getting a sensible argument developed.
So if he adjusted the assumption in his DICE model, could it be useful or not because it doesn't have the energy component that you're talking about?
It could be useful if you had a 1 over quadratic function for the damages function, because that would give a vastly different answer. Now, that itself is very sensitive to the numbers you give. So, for example, if I've been looking at my little graph I've put together here right now, if I say 6 degrees is that magic, when you talk about things like a level of climate change, once you've got a certain percentage, like a 6 degrees, then the runaway process of the planet can take you to 10 pretty easily. So I put in 6, I get this enormous increase in the slope of the line. If I instead say it's 7 degrees, then I get it takes a lot longer to reach that crisis point. So it's a very again, this stuff can be very sensitive to the numbers you put into the system to begin with. But it could be more useful for the realistic function there, but still massively misleading.
And you've got to look at that, as he did with his measure of economic welfare. You've got to look at the distribution of income rather than just what the growth rate as a whole is. Because let's look at the United States, for example, has a very high GDP per capita, a lot more than Europe. But are they actually any better off individually than Europeans are? I'd argue actually the Europeans have probably got a better lifestyle, better standard of living, even though their GDP per capita is lower. So can you actually make less and spend less and be just as well off? And that has to be the fundamental question, doesn't it, about how we adapt the standard of living, and can we do that without growth?
That, I think, is a reasonable argument, but I'm not particularly fussed by it because, again, that sidetracks from the actual analysis itself and saying that the analysis of it is completely skew-if. Even if we make those concessions and say, yes, GDP is not that important, when you weight it, you're still weighting a nonsense argument that a 25-degree increase in temperature will only reduce GDP by a factor of 1.6, when there'd be nothing left. Not even micro. I don't even know that any anaerobic microbes will be alive at 25-degree increase over current temperatures. So it isn't just that the GDP is a bad measure. That's an easy way out for somebody like Nordhaus. His model's nonsense.
So it would be good to have a model that worked, though, wouldn't it? Because I think if you went to people, the population as a whole, there will always be. There's climate change deniers who listen to this podcast, as we know, because they've got uppity.
But I hope they're not people who deny that the planet would be unlivable if it was 10 degrees hotter or 10 degrees colder.
No, they just don't think it's going to get there, I suspect. But if we had a strong economic model that said, if we carry on doing this, if we have growth at this level, this is what's going to happen. Therefore, we need to, growth needs to be at this level. Most people, I think, would say, well, okay, if we had an understanding of how much we had to compromise our living standard to protect the planet, then people would be voting for that sort of change, wouldn't they? Because I think, give people the choice, continued growth and improvement in your living standard or degradation of the planet as a part of that process, or the alternative where you have slower growth and the planet is preserved. You take the latter option. Most sensible people would, if you really knew the numbers behind it.
And that's what limits to growth is so important. And this is why economists, especially Nordhaus, played a major role in destroying its credibility and stopping it being taken seriously. When you look at work by Graham Turnover about 8 years ago, the forecasts they made are still pretty much spot on what's happening globally. So if it hadn't been for Nordhaus, we might have actually made those sorts of decisions back in the 80s. But he played a major role in making sure we didn't even consider the argument. And bang, look where we are now.
All right. Well, William Nordhaus, you might be hearing it first, a Nobel Prize winning economist for 2019. The Nobel Prize being the alternative to the Nobel Prize for the people who have deflected the course of economics the most, I guess is how you describe it.
That's very accurate, mate. Yep, we'll get you on you can do the announcement.
All right, cool. Look forward to it. All right, great to talk again, Steve. Catch you again very soon.
Okay, bye.
And I think next time we're going to look at hyperinflation. How do some countries find that their economy suddenly turns into a downward spiral of hyperinflation, while other parts of the world at the same time are struggling to see anything in the way of inflation almost at all? We'll look at that next time on the Debunking Economics podcast with Professor Steve Keen. Join us for that one. I'm Phil Dobbie. I'll see you then. If you've enjoyed this podcast, then please share it with your friends, like it on YouTube, and subscribe to this channel.